Hi, my name is Rushdy Bin Ab Rashid. I am from Group 1, RK23, and today I will present about Power Project, title, Analysis of Three-Phase Wire-Connected Generator. Okay, we start with the introduction. For most of the electrical energy used in the world is alternating current, or AC, where it uses three-phase system. The value of alternating current fluctuates between a maximum positive value and a minimum negative value with a zero reference, which is named neutral or ground. This current is a sinusoidal wave. When only a single sine wave is generated, the electrical current is referred as a single-phase current. Three-phase alternating current electrical energy is generated by three-phase generators and transmitted over three-phase circuit systems and wiring. We can see by three-phase circuit as three single-phase circuits consolidated into one circuit system with either three or four wires. Each one of the phase or wave generated can be separated using two wires only. Using these single waves, single-phase motors, and other single-phase loads may be operated from a three-phase circuit. In industrial operation or whenever it is available, three-phase circuits are preferable to use over single-phase circuit. There are several reasons why three-phase is preferable to single-phase for service in so many applications. Okay, this is the reason why three-phase is preferred to single-phase for service in so many applications. Okay, we start with one, specific horsepower or kVA rating. Uh, for specific horsepower or kVA rating, it's because physical size of the three-phase motor or generator is smaller than that of the single-phase unit. The capacity of a three-phase generator or an induction motor is about 150% of that a single-phase machine of comparable frame size. Next, two, we start with 2.1 single-phase system. The power delivered by a single-phase circuit is pulsating. In figure 1 that I will show you later, sinusoidal wave patterns of voltage, current, and power are shown for a resistant load, as the figure 1 shows. The phase between the voltage and current is the same. This means that the power factor of this system is unity. Unity is about power factor is the cosine of the angle between voltage and current. At unity power factor, the power factor is 0 twice each cycle. I will show you figure 1. Okay, this is figure 1. The top one is figure 1 that we're talking about in 2.1. And 2.2, three-phase system. The total power supplied to a balanced three-phase circuit is not a variable wave but is a constant value. And also, adding the power for all phases together at any time will create a constant value. Mathematically, the above can be easily proven. For balanced three-phase circuit, the addition at one point of all the three-phase voltage or all current at every instant adds to zero. Okay, all that is can be referred at figure 2. Where is the phase 1, phase 2, the pink, the purple one, and phase 3, the yellow one. And the total power will be the light blue. Okay, next. Um, this is also the continue of 2.2 about three-phase system. A three-phase generator supplies a three-phase circuit with three separable voltage of the same frequency and magnitude but 120 electric. by 120 degrees apart. Okay, as indicated above, only two standard connections are used in three-phase work. Two-phase system use to connect single-phase load, which are Y and delta connection. And in this study, students will focus on three-phase Y-connected generator, transmission loss, and a load with acceptance power factor lagging and frequency estate. According to Electrical Supply Application Handbook V3, or we call it ESA V3. Okay, next we continue with the objective. First, to analyze the three-phase Y-connected generator in electrical system, and two, to evaluate the parameters of the connected Y generator in the context of transmission and load impedance, currents, and voltage acceptable voltage drop. And three, to study and evaluate the active power absorbed by the loads by using two wattmeter method and the conventional measuring method. Okay, next to the methodology of this project. Okay, for first, this project is assigned by the lecturer, and I find all parameters and construct the YY circuit. The YY circuit that being constructed, and also get all the calculated value with PSIM simulation compared. And also then the discussion were made with the result achieved, justifying the standard, and has a conclusion on this project. And last, submit the report to be evaluated by lecturer. Okay, next. This is figure 3 that being constructed by PSIM simulator. And this is the result, the signal that we get using PSIM simulator by this YY circuit. This figure 4 shows that the values between IA versus VAC, and the bottom one is IB versus BBC. Okay, thanks. Okay, this is the results and calculation that I made with the PSIM value, and also the value that being given by lecturer. Some of the value is using my metric number. My metric number is 18, 18, 18, 10, 9, 1, 3, 4, 6, 18, 10, 9, 1, 3, 4, 6. Okay, this one. Okay, this one is A, B, C, and D. And then we calculate the E line, E phase, and then we calculate the current line for I phase. And after that, continue with E phase, and then after we obtain the E phase, we can find the value of voltage drop. Yeah, the V drop is using the V supply minus V load over V supply times by 100%. And I got the V drop value is 36.77%. This is the second calculation. Continue that previous calculation. After I get this V drop, I can calculate this V load from load A, load B, and load C. After that, for wattmeter method, based on ESA V3 for the PF value for factor PF lagging 0.9 for voltage level. Okay, I got cos negative point. This is for factor. I got 225.8419. Okay, and last I will got the P load. The P load I got is very high, 5309448.645. Okay, next I will continue with the discussion. Okay, for the discussion from the above results, it shows the line currents, which is IAA, IDB, and also ICC, from the calculated value of the line currents obtained from the measured value of line current from PSIN. The measured values of the line current are slightly different as being compared to the calculated value of the line currents. Plus, the results show the value of the phase voltage of the load, phase voltage of load A, load B, and load C were calculated and recorded. And there is slight differences between the value of phase voltage measured as in the results. From the result, we can conclude that the value calculated of the phase voltage of load is slightly less as compared to the phase voltage of the load calculated. Then the result shows the values for line EAN, EBN, and also EC. The values of calculated lines voltage have slight differences as compared to the values of measured line voltage as observed from the table. The values of measured line voltage is slightly less than the values of the active power gained by the loads. They are a bit different in the value of calculated active power as being compared to the measured active power using two wattmeter method, as it is obtained by the value of the measured active power using two wattmeter is less than of calculated active power. Okay. Hence, the value of the voltage drop percentage with the 33 kilovolt of generator is 47, 56%, which means it had exceeded the acceptable voltage drop based on BS 7671 or any Malaysian authority standard. We continue with the conclusion. The conclusion, why configuration is used to distribute power to everyday single-phase appliances found in home and office. Since the insulation is decided by phase voltage and for wire connection is 0.577 times line voltage. For delta connection, phase voltage and line voltage are equal since the insulation level is decided by phase voltage, and for wire connection, phase voltage is 0.577 times line voltage, and hence insulation required in wire connection is nearly 57.7%, where can be used for high voltage generation. Then the insulation that will be required in delta configuration for same line voltage, and hence cost for insulation will be reduced. Neutral point, that neutral wire can be drawn using the neutral wire, and any one phase can be used as single phase. Okay, this is the reference um, from the presentation that I made. There are three references, one from TMB and one from Wikipedia and one from engineering.com. Okay, that's all from me. I hope this project is okay and I will get it. Okay, thank you.